Welcome to our video on the applications of conditional probability, focusing on the law of total probability. Now, in the past, with our previous videos, we've already seen that the probability of A given B, this is conditional probability when you've got a given in it, is equal to the probability of A intercept B over the probability of B. And of course the probability of B can't be equal to 0 because then we'd be dividing by 0. Now the total law of probability says that the probability of B equals the probability of B given A times the probability of A plus the probability of B given A dash times the probability of A dash. Should be a dash in there. So you should recall from previously, because we're going to rearrange this one a little bit to make it into a more useful format for us. The probability of B given A, you should recall, is equal to the probability of B intercept A over the probability of A. And you will also recall, using the same formula, that the probability of B given A dash equals the probability of B intercept A dash over the probability of A dash. So when we take these two and go back to this formula, we can write that the probability of B equals, so it's the probability of B given A, which is this. So I'm just substituting it in. B intercept A over the probability of A times the probability of A plus the probability of B given A dash, which is down here, B intercept A dash over the probability of A dash. That's B given A dash, and then we times it by the probability of A. A dash. I keep forgetting that dash on the end there. Make that bracket look a bit nicer. Okay, what we've got here is divided by probability of A times probability of A, so these two you might have noticed will just cancel out. Same with these two. So we end up with the probability of B is equal to the probability of B intercept A plus the probability of B intercept A dash. And that's another format for the total law of probability that you might find useful when you're solving some probability problems. Okay, example 1 says, in a certain country town, if it rains on one day, the probability that it rains again on the next day is 0.7. If it stays dry on one day, the probability that it rains on the next day is 0.4. Part A, given that it is dry on a Monday, find the probability that it rains on a Wednesday. And part B, given it's dry on Monday again, what's the probability that it rains on a Thursday? So working with part A first, always with probability questions, the first thing we need to do is define our events. And we've got here either it rains or it doesn't rain. So I'm going to go for R, for it rains. and we've got rains Tuesday or rains on Wednesday. So I'm going to put a TU because later on we're going to be doing raining on Thursday, which will be TH. So this is just a subscript. Doesn't rain on Tuesday will be R dash Tuesday. Rains on Wednesday, we can just use a W for Wednesday. And doesn't rain on Wednesday. You could have chosen A and A dash, or you could have chosen D for dry here and D dash for raining, not dry. Completely up to you, but you do need to make sure that you define your events before you start solving any problems. The second step when we're solving probability problems is to write down the information we have from the worded problem in the question. So we have here, if it rains on one day, the probability that it rains again on the next day is 0.7. So that would be the probability that it rains again. So that would be Wednesday, given that it's rained on Tuesday, equals 0.7. If it stays dry on one day, the probability that it rains on the next day is 0.4. Now, we've said it's dry on Monday, so that would be this day if it stays dry on one day. So the probability that it rains on Tuesday is 0.4. Need a U on there. The probability that it doesn't rain on Tuesday is just going to be 1 minus 0.4, which is 0.6. And that's all the information we've got so far. We're trying to find the probability that it rains. Oh, given that that it's dry on Monday, what's the probability that it rains on Wednesday? So we're trying to find the probability that it rains on Wednesday. Now we can use our law of total probability to help us with this. So I'm going to write it out in the first way it's written, first of all, which is using A's and B's, equals the probability of B given A times the probability of A plus the probability of B given A dash times the probability of A dash. I'm now going to substitute in for A and B these two events that we've got up here. So Tuesday will be the A event and Wednesday will be the B event. So we can say the probability that it rains on Wednesday, which is what we're looking for here, handy, equals the probability that it rains on Wednesday given it doesn't rain on Tuesday times the probability it doesn't rain on Tuesday plus the probability it rains on Wednesday given it rains on Tuesday times the probability it rains on Tuesday. Now I've just realised I've put these back to front a little bit. So that one is this one with the dashes, and this section here is this one. Okay, let's substitute some values in. The probability it rains on Wednesday given that it doesn't rain on Tuesday is going to be 0.4 because it's going to be the same chance that it rains on Tuesday, which is 0.4 here, if it hasn't rained on the day before. Multiply that by the probability that it doesn't rain on Tuesday, which is 0.6, plus the probability that it rains on Wednesday given that it rains on Tuesday. Rains on Wednesday given rains on Tuesday, it's 0.7. Times the probability that it rains on Tuesday, which we've already found here, is 0.4. Multiply these together and you should get 0.52, which is the probability that it rains on Wednesday.